Hello friends, welcome to my channel. Here solve LeetCode problems. Today's problem number 1611, minimum 1 bit operations to make integer 0. Given an integer n, you must transform it into 0 using the following operation any numbers of times. First, change the rightmost bit in the binary representation of n. Change the I bit in the binary representation of n if the I-1 bit is set to 1 and the next bit, all bits are set to 0. Return the minimum number of operations to transform n into 0. This problem is hard level and it's definitely not simple. What can we do? For instance, we have some number like this. First of all, let's solve sub-problem, which is how many operations we should make to transform this kind of number. So we keep only 1 in the first bit and all other numbers will be 0. This number equals to 2 in third power and equals 8. First of all, we write some function which calculate how many operations we will need. So it will be function f of k, where is k is the power. And let's do it. First of all, what we need to make first 1 into 0. We need to change number to the next form. So it will be 1, 1, 0, 0. In this case, we can change first 1 into 0. So we need somehow make first 0, change it into 1. How we can do it? If you can see it the same as initial problem, but with k equals to k minus 1. So it is the same how to make 1, 0, 0 into 0. It's the same as how to make 0 to 1, 0, 0. So it takes f k minus 1 operation. So next we can change first bit. So we can do it in one operation. And last thing, we need to make second bit 0. It's the same that we did previous, so we can make whole number 0 and it takes also f at k minus 1 operation, because it's the same as previous where we change second bit from 0 into 1. And so total f at k takes f at k minus 1 2 times plus 1. So let's implement this first sub-problem. It will need it later. So create some function f with one argument k. And we need base case. Base case if we have only if k equals to 0, in this case we just return 1, because in this case the number equals to 1 and we can change it into 0 just change this bit. And return to multiply f at k minus 1 plus 1. And let's add cache annotation. It's to improve this the function performance, because if we already calculated f of some k, it will return the result immediately without any additional calculations. So next, let's think how we can calculate whole numbers. We can think this is some power of 2 plus rest number, so 1, 0, 1. First part we already know, so let's call whole function as m, so m of n equals to our function f of k plus, and we can calculate the rest part as recursively, like its function m, the same, but in this case it will be with n1. n1 is the same number of n without the most significant one, so it's without first bit. It should work, and we can do it, but we have to find the minimum count of operation, so we can find the count of operation less than f at k plus m of n1. How we can find f? So we can think that f at k, it's in our case 1 and 3 zeros. We can think is m of n, so it's our answer, so it's total count of operation, and we can change initial number to number f at k just to change 1, 0, 1 into 0. So to do it, it's f at n1. And finally, our answer, it's f of n, it's m of n equals to f at k minus m of n1. You can see it's better than f at k plus m at n1. Let's do it. First of all, we need to find k. To do it, we can multiply current by 2. How many times? While car less or equals than n. So while 2 multiply car less equals than n, car multiply by 2, k plus 1. And finally, let's return f of k minus, and the recursive call this same function, and we need to pass the n1, so it's the n without the most significant bit. We can do it, if you can see here. So we need to transform initial value into the number without most significant bit. We can do it if we make XOR operation with 2 power k. XOR operation compare bits of two numbers, and if the bits are equals, it will be 0. If bits are different, it will be 1. So total result will be what we need, 1 0 0. So here, let's do it. And don't forget to add best case. In our case, best case will be if n equals to 0, return 0. So we don't need to do anything. Let's check the tests. Something goes wrong. Yes. Check again. It works, so let's submit it. It works. Thanks for watching. See you tomorrow. Bye.